You have been lied to about Saturn's rings. Not maliciously, not deliberately, but every illustration, every classroom poster, every documentary you have ever seen has shown you Saturn's rings as if they are a permanent feature of the solar system. As if they were there when the dinosaurs walked. As if they will be there when our descendants, millions of years from now, look up at the night sky. They were not, and they will not be. Saturn has had its rings for, at most, 400 million years. The dinosaurs did not see them. The first dinosaurs appeared roughly 230 million years ago, when the rings may not have existed yet, or were just forming. The rings are new, cosmically, absurdly, shockingly new. And they are already leaving. Right now, at this exact moment, Saturn's rings are falling into the planet. Not slowly drifting, not gradually fading, actively falling, measured, quantified, confirmed by a spacecraft that died to find it out. The most beautiful structure in the solar system has an expiration date, and it is sooner than you think. Before we talk about why they are disappearing, you need to understand what they actually are, because the reality is nothing like the smooth golden bands you have seen in pictures. Saturn's rings stretch nearly 300,000 kilometers from their inner edge to their outer edge. That is roughly 75% of the distance from Earth to the Moon. They are wider than the distance you would travel on a road trip across the United States 6 times, and yet in most places they are less than 100 meters thick. A structure 300,000 kilometers wide and 100 meters thin. If you scaled Saturn's rings down to the size of a piece of paper, standard printer paper, 0.1 millimeters thick, that paper would need to be nearly 300 meters across to maintain the same proportions. The rings are, by any measure, the thinnest large structure that exists in the solar system, and they are not solid. They are not the smooth golden bands you see from Earth. They are a chaotic, churning blizzard of ice and rock particles ranging from microscopic dust grains to boulders the size of houses, all orbiting Saturn at thousands of kilometers per hour, constantly colliding, shattering, and fusing. If you flew into the rings, you would not glide through a field of glistening ice. You would be destroyed in milliseconds by the continuous high-speed bombardment of a particle storm that has no gaps large enough to navigate safely. The rings are also not uniform. There are distinct regions named with letters, in the order they were discovered, not the order they orbit. The A ring, the B ring, the C ring, the F ring. The Cassini division, a gap 4,800 kilometers wide that looks empty from Earth, but is actually filled with faint, dusty material. Each ring has different density, different particle size, different age, different origin. And each ring is disappearing at a different rate. In 2017, the Cassini spacecraft was dying. It had spent 13 years in Saturn's system, the most productive planetary mission in NASA history. It had discovered active geysers on Enceladus, lakes on Titan, the hexagonal storm at Saturn's North Pole. It had answered questions that scientists had debated for decades, and it had one final mission before NASA sent it to its death. In the last 5 months of Cassini's life, NASA directed it into a series of orbits that no previous spacecraft had ever attempted, diving repeatedly through the narrow gap between Saturn's innermost rings and the planet's upper atmosphere. 22 times. 22 passes through a region of space so dangerous that scientists were not certain Cassini would survive the first one. They called this the grand finale. In those 22 orbits, Cassini's instruments measured something that had been theorized but never directly confirmed. Material from Saturn's rings was falling into the planet's atmosphere, continuously, in enormous quantities. Cassini's mass spectrometer detected a rain of water ice, organic compounds, and complex molecules streaming down from the rings into Saturn's equatorial atmosphere. The instruments measured the quantity, the rate, the composition. The result: Saturn's rings are losing between 400 and 2,800 kilograms of material every single second. Every second. At the low end of that estimate, 400 kilograms per second, that is, the weight of an average car disappearing from the rings every second. At the high end, nearly 3 metric tons per second, continuously, without pause. The rings are not gently fading. They are actively, measurably, rapidly depleting. And at that rate, the Cassini team calculated, the rings have between 100 million and 300 million years left before they are completely gone. That sounds like forever. It is not. The dinosaurs went extinct 66 million years ago. If the lower estimate is correct, the rings have less than twice the time the dinosaurs have been gone before they vanish entirely. We are not watching an eternal structure. We are watching the last act. Now, let's talk about the actual physics, because ring rain sounds poetic. But the real mechanism is more precise and more unsettling than the metaphor suggests. The particles in Saturn's rings are not neutral. They carry an electric charge. When ultraviolet light from the sun and charged particles from Saturn's own magnetosphere strike the ice particles in the rings, they knock electrons loose. The particles become positively charged. And Saturn, like Earth, has a magnetic field, a powerful one, generated by its vast metallic hydrogen interior. Charged particles in a magnetic field do not move freely. They follow the field lines. Saturn's magnetic field lines connect the rings to Saturn's upper atmosphere. The positively charged ring particles, freed from the gravitational balance that kept them in orbit, begin to slide down these invisible magnetic highways pulled toward Saturn's equatorial atmosphere by the combined force of gravity and magnetic alignment. They enter the atmosphere as a constant drizzle of ice, water vapor, and organic molecules. This is ring rain, but magnetic charging is not the only mechanism. Micrometeorites, tiny space rocks, barely larger than grains of sand, constantly bombard the rings at high velocity. Each impact vaporizes a small amount of ring material and ejects it from the ring plane. Some of this ejecta escapes Saturn's gravity entirely. Some falls inward toward the planet. Particle collisions within the rings themselves also spread material, the continuous grinding of ice against ice, boulder against boulder, slowly powdering the largest particles into dust, too small to maintain a stable orbit. And then there is the Poynting-Robertson effect, the subtle, continuous pressure of sunlight on small particles, which over time causes them to slowly spiral inward towards Saturn, losing orbital energy to the very light that illuminates them. 3 separate mechanisms, all working simultaneously, all pulling material out of the rings and either sending it into Saturn's atmosphere or ejecting it into space. The rings are being eroded from above, from below, and from within. And here is what makes the timeline truly alarming. The rate is not constant. It is accelerating. As the outer rings lose material, they become less dense. Less dense rings are more vulnerable to the same processes: the magnetic charging, the micrometeorite gardening, the Poynting-Robertson drag. Each kilogram lost makes the next kilogram slightly easier to lose. The rings are not dying at a steady rate. They are dying faster and faster. This brings us to the question that should genuinely unsettle you. If the rings are losing material this fast, if they have been losing material at this rate or faster for their entire existence, then how young were they when they started? Working backward from the current mass of the rings and the measured rate of depletion, scientists have calculated that the rings could not have been significantly more massive than they are today for very long. The math simply does not allow for rings billions of years old at the current depletion rate. In 2019, a study published in the journal Science using Cassini's grand finale gravity measurements confirmed the conclusion. Saturn's rings are between 10 and 100 million years old, at most 100 million years. The solar system is 4.5 billion years old. Saturn itself has existed for all of that time, a gas giant that formed in the first few million years after the sun ignited. But Saturn did not always have rings. For more than 4 billion years, Saturn was ringless, a gas giant like Jupiter, like Uranus, like Neptune, massive and impressive, but without the halo that makes it the most recognizable planet in the sky. Something happened, roughly 100 million years ago, that created the rings. The leading theory, the one consistent with both the age and the composition of the rings, is the death of Chrysalis. A moon, perhaps the size of Iapetus, orbiting Saturn for billions of years in stable orbit, until gravitational interactions with Saturn's other large moons disrupted its path. It drifted inside the Roche limit. Saturn tore it apart. The debris spread into a disk. The rings we see today, the rings that have defined Saturn in every human illustration for the past 4 centuries, are approximately 100 million years old. The first flowering plants on Earth are older than Saturn's rings. Tyrannosaurus rex is older than Saturn's rings. We found Saturn just in time. Not in human time, in cosmic time. We happened to evolve, develop telescopes, and look up at the sky during the precise geological window when Saturn wears its rings. A few 100 million years earlier, no rings. A few 100 million years later, no rings. We caught it in the act. But the rings are doing something else to Saturn that nobody talks about. They are affecting the planet's axial tilt. Saturn is tilted at 26.7 degrees from vertical, a moderate tilt, similar to Earth's 23 degrees. For a long time, scientists assumed this tilt was ancient, a remnant of Saturn's formation or some early giant impact. In 2022, a team at MIT published a paper proposing something far more unsettling. Saturn's tilt was caused by the rings. The mechanism involves resonance. Saturn's rings create a gravitational asymmetry, a subtle imbalance in how Saturn's mass is distributed. This asymmetry interacts with the gravitational pull of Neptune, whose orbital period happens to resonate with Saturn's precession rate. The two gravitational influences lock together, and over time, they have gradually pulled Saturn's spin axis away from vertical. The rings tilted the planet, and when the rings disappear in 100 million years, that resonance will break. Saturn's axial tilt will slowly change. The planet will gradually right itself, or tilt differently, over millions of years following the loss of the rings. The rings are not just decoration. They are actively shaping the planet that wears them. And when they go, Saturn will be a fundamentally different world, not just visually, but structurally, dynamically, gravitationally. Let's spend a moment with the thing nobody wants to picture. Saturn without rings. Strip away the A ring, the B ring, the C ring, the Cassini division, the F ring, and its shepherd moons. Remove 3,000,000 kilometers of frozen debris. Take away the halo that has made Saturn the most recognizable planet in the solar system. Since the first time, Galileo pointed a telescope at the sky in 1610 and saw something so strange he thought Saturn had ears. What is left is a gas giant, yellow-brown, banded, enormous, but ordinary. The same category of object as Jupiter, the same category as Uranus and Neptune, a planet defined by mass and atmosphere, not by the structure that made it unique. It will still be the second largest planet. It will still have Titan and Enceladus and more than 140 other moons. It will still have the hexagonal storm at its north pole and the great white spot that erupts every 30 years. But it will not be Saturn, not the Saturn we know. There is a melancholy to this that is difficult to articulate precisely. Humans have known about Saturn's rings for 400 years. They appear in our art, our science, our metaphors for beauty and perfection. They are the first thing children point to when you show them pictures of planets. And they are a temporary accident, a 100 million year window that opened when a moon crossed the wrong boundary. We are living inside that window, right now. This is it. There is a concept in astronomy called the anthropic window. The idea that what we observe about the universe is shaped by the fact that we are here to observe it. We exist now, not 500 million years ago, and not 500 million years from now. Saturn's rings exist now. That is not a coincidence you should take lightly. In the full 4.5 billion year history of the solar system, Saturn has worn rings for perhaps 100 million years. That is roughly 2% of its life. If you spread the solar system's entire history across a single calendar year, Saturn had no rings from January through late November. The rings appeared sometime around December 10th, and they will be gone by December 13th. We appeared on December 31st. In the last hours of the last day of the cosmic year, we opened our eyes and looked up, and there they were. The most beautiful structure in the solar system, present in the sky at precisely the moment we developed the ability to see it, photograph it, send robots to measure it, and understand what it is. We will be gone long before the rings are. Our sun has 5 billion years of fuel remaining. Humans, if we survive, will still be here in 100 million years. Future generations of humans, or whatever intelligence follows us, will look up at Saturn and see nothing but a gas giant. They will read about the rings in historical records, if historical records survive, and struggle to imagine what the planet looked like. The same way we struggle to imagine a world without them. Right now, tonight, if you have access to a telescope, even a small one pointed at Saturn, the rings are still there, still bright, still perfect, still catching the light of a sun that is slowly destroying them. Look at them while you can, because in the universe's timekeeping, the window is almost closed.